VCP NV Objective 4. The presenter will be Paul McSherry today, who's working as a trainer for one of the training partners and actually does give the ICM courses for the VCP NV. So we are in good hands today. And if you have any questions, you can simply raise your hands. You can use the vBrownBag hashtag on Twitter, or use the tool chat, and I will relay the questions then to Paul. And with that, over to you, Paul.
Thanks very much, Frank. Thank you. Well, welcome everyone. Let's see if I get a little pop-up saying I'm a presenter. Here we go.
Yep.
Yeah, we've got that, and I'll just make sure everyone can see my screen. Can you see my screen now?
Yeah, that looks good.
Excellent. Cool. Okay. So, all pencil. Everyone still there? Can you still see me?
Yep, we can.
Excellent. Excellent. Cool. Cheers, Frank. Okay, welcome everyone. So the next 45-50 minutes talking about VCP NV Objective 4. So just a couple of seconds about me because I'm not very interesting. I'm a freelance contractor from the UK. It's a bit of a selfie from me there beside VMware. I'm interested in anything with a little v. I work between 4 or 5 different clients, so I spend about 70% of my time in the real world and about 30% of my time teaching. So I'm a VCI. I've been a vExpert since 2012, and recently I passed the VCP NV. So my story with NSX is that I was honoured to be invited over to the States, to Palo Alto, and I had a week's intensive training with Chris McCain and a guy who's a VCDX, also NV, called Elva, who's a fantastic trainer. But I'm not a network guy. I'm just a admin who's trying to learn trying to find my way around this big product that VMware keep telling us about. So there's a few bits and pieces throughout this presentation that I'm going to be placing on my blog. Also practice tests and things associated with the exam are on the bottom link. The session overview, main aspects of Objective 4. So I'm going to set the scene, reintroduce people about what NSX is, how great it is, and then work through mainly install. So looking at the logical components, how they connect to each other, and then do a quick walkthrough of how you'd install it. And then maybe towards the end, a quick hints and tips that I found from my exam that would help you along the way. So that's my aims. And then getting rid of some FUD. We've got talking to the network engineer. So normally in my life, I have great respect for network engineers, but I'm not one. So you try and get across what you need while he looks confused at you. So NSX has that crossover thing as well that we have to look about. And then an overview of the upgrade process and some useful links to other people to jump off, look at other things. So what is NSX? In my head, it's a toolkit. It's not a particular product. It's an enabler to allow you to bring the intelligence of a network whether there's an ESX hypervisor footprint. So leveraging the compute stack to maybe simplify or automate, program your network stack. But you still need to talk to your network engineer. So it gives the ability to go above normal VLAN restrictions, so 4094 VLANs. It's stretching a layer 2 over a layer 3 and gives you some great functionality along the way. Multi-tenancy. So previously I've worked at several firms that they don't really care about what NSX will give us from a technical perspective. But from a business perspective, I've got an app. I can clone it, I can copy it, I can back it up. The problem is I need to change the IP range. If I change something on that, it automatically means it's a regression test. Also, from a service provider point of view, you can combine this together, and then you don't care what people use from the network side. The network segment or the transit is completely static. So you set that up and let the programmers go nuts, in my head. So combined with the distributed logical router and the firewall functionality, hairpinning, which we'll go through in a bit later on, and security features that says this VM can't talk to this VM, or any VM that starts with VDI can't talk to prod. These are the power that NSX can give a client. But it's normally meant, it's got a powerful API, meant to be a consumer model, so portal-based, self-service, VCAC type platform. And it gives you self-service cloud platforms, so private cloud, service provider, those sorts of use cases. So from a conceptual point of view, you have a stable transit network, and then your compute stack. So we're going to be talking about this concept, then logical, and then we'll go into our walkthrough. So physical network, what do you need before you do anything? You need something stable, a vSphere 5.5 platform, HADRS, and a physical network. And there's some prereqs, such as the MTU size, what the VXLAN replication is going to be. We'll talk about that. And then you import or put all the intelligence within this compute stack. So you've got your management plane with your NSX manager and your vSensor, your NSX with your programmable functions, your VXLAN providing the overlay abstract virtual wire. So the workloads on the top, those MAC addresses are never seen on the physical network. It's going across a VXLAN, which we'll go through. So here's my whiteboard. Excuse, I didn't have much time to put all the Visio together, but I have tried certain bits. So from a component level, the exam, the VCP exam, is not, I was just saying to Frank, I think Frank said it, it's not a VCAP exam. It's everything you need to know to get it working. So the actual components, the bits around the platform, how it links together, and enough to talk to someone in the support team if you've got a problem. So that's how I've looked at it. So you have your vSphere cluster at the bottom, this compute stack. You have a VDS, which is your virtual distributed switch, which gives you a port group, which then gives you your VTEP. And your VTEP is your tunnel endpoint for your VXLAN. So you're putting a VXLAN across your ESXi cluster and giving you switching. So this switching, this is above in this control plane, so switching to switching. So NSX controller, which has your MAC, your ARP, and your VTEP table, they're VMs. So we're going to be looking at installing them. Our logical control VM for our router, we have one per instance of DLR. This is responsible for LIF programming, which is the logical interfaces, and dynamic routing peering, so RSPF peering, maybe to an edge gateway. Then our management plane, so our vCenter that we all know and love, and then this new device called the NSX Manager. So this NSX Manager is an appliance. It's a one-to-one relationship with your vCenter. It's also an API endpoint. So that's where the RESTful API is. And it's also the endpoint for VCAC and your consumers. So this is your point where you program and develop your platform, but you're not reliant on it for network communication. So the majority of the platform, such as switching, routing, your firewall, are in VIBs or modules installed by VIBs. So these modules, ESXi modules that you install from the NSX Manager. So you push the config to the hosts, develop this virtual wire, and then place your workloads within it. So from the exam perspective, it's understanding the components, the order of how you install them, what the relationship between them are, and we'll gradually work through that. So from this point of view, the first thing you get is an OVA, which is your NSX Manager. You download it and you import it into your stable vSphere platform once we've met the prereq. At that point, you can deploy your platform by registering the NSX Manager to the vCenter and then using the vSphere web client. So if you're not a fan of that, get used to it. I think the more I use it now, the better I feel with it. And it gives you a new area called networking and security, which allows you to configure the majority of the platform. So going on, we've got a nice little animation whiteboard here. You have your NSX Manager. Which then you OVA, install it to virtual appliance, register it using a web GUI, which we'll walk through, register it to your vCenter, which is your way in to your compute stack, where you're going to place VIBs, which is added modules into ESXi, which is your compute stack here, which is a VM kernel port, it's a DB port group, with an NTU of 1600 between the ESXi's on that NSX enabled domain. And you make VTEPs, which attach connected through your physical network with your VNI, so 5001. They all begin to start with 5000 once you go above the 4094, so you can distinguish between VXLAN and VLAN. And you push these VIBs. The order is NSX Manager, install that, deploy it, register with the vCenter, then make your controller, which is here. So our controller is in a cluster. So you have 3. There must be odd numbers, so 3, 5, and 7. 3 is the recommended. 3 reaches the scalability of a vCenter maximum, and they must see the majority, meaning if I lose 1, it will carry on working because I've still got 2. If I lose 2, I can't see the majority, so I will leave the cluster and the cluster will be disconnected. And the controller cluster is used as a MAC, ARP, and VTEP table and programs through to the VIBs. So that's your control plane for your communication. So it's not in this part of the presentation, but in other objectives you would go through the walkthrough on how a VM would talk on one host to another VM on the same host, and then if it crosses hosts or crosses segments, you need to be able to communicate by stretching the layer 2 over layer 3, and the controller cluster in unicast and hybrid would help you along the way. So anti-affinity rules are not made by default, so you get to create them, and they use a concept called slicing, where it takes this MAC, ARP, and VTEP table and spreads them across the load to leverage your compute stack. So they're the major components of the platform. What the NSX Manager is, so that's your RESTful API endpoint, the virtual appliance that you import using the web client. Give it an IP address. A few things to consider is that you need to have an NTU size of 1600, so 1550, plus an added bit, just in case you do any VLAN tagging inside a virtual machine. And I think the big thing that came out of a few training courses I've done in the past, or a few questions I've had around the NSX platform, is that some people think it's bye-bye network engineer. It's not. Network engineers are a lot more important now within the VM platform. But also there's a real crossover in technology and a crossover in skill set. So you may have a network engineer who knows nothing about VMware, and you may have a virtual admin who's kind of dangerous with networking. So it's really communicating. The VCP is about communicating what you need with a network engineer. So for example, what changes do you need to the platform to enable you to do a POC or to install NSX in the data center? So a few prereqs are you need vSphere 5.5, Enterprise Plus, You need vCenter 5.5. You need a stable platform, so I look at it as a compute stack HA cluster with automated DRS. And then a MTU size change of 1600 between the ESXi nodes for the VXLAN traffic. And then you've got some choices. How would you stretch the MAC, the ARP, and the VTEP traffic across the platform? So how do you stretch this traffic between over the layer 2 across this layer 3? So there's 3 choices: unicast, hybrid, and multicast. So unicast requires just an MTU change. It puts everything inside the hypervisor. It's more load on the hypervisor, and it sends it in unicast by one at a time. So I send it to A, I send it to A, I send it to A, then I send it to B, then I send it to B, then I send it to C. With hybrid, that's another mode. You can offload some of the process to maybe the top of rack switch. For example, you need to have IGMP snooping on the switch, which allows you to say if there's a multicast being sent, so it's multicast locally within the segment. So for example, you have 3 racks. Those 3 racks are 3 different segments, meaning 3 different network IDs, or 192.168.1, 2, and 3. If you want to stretch this information across using the layer 2, the VTEPs will be the endpoints in those platforms, and then you would stretch the MAC, ARP, and VTEP across that. Locally, it will be multicast. It will then send unicast to an area on the remote segment, and then multicast locally. So you offload a lot of the work locally, but you still don't have to enable multicast across your full segment. Then there's multicast, which means you offload everything. You don't use the controller as much for this function, and it allows you to take full advantage. But from a network conversation, when you talk to a network engineer, in my experience, if you go and ask for a trunk port, they sort of look at you saying, why do you want a trunk port? If I go up and say I want an MTU change, that'll raise their eyebrows. If I then say, I want you to enable multicast across this segment of my compute stack, then probably want a big long conversation. So these modes can support that. Each of the use cases, so ease of entry, unicast, offloading it locally with IGMP sleeping on the hybrid, and multicast across the whole of the segment. So here's a quick animation on this. So you've got a transport network with an MTU size of 1600. You've got your compute stack, so you've got 2 racks in different networks, so 192.168.1.x and 2.x. You have your ESXi installed, your DB switch, your NSX manager, and you push VIBs. These VIBs are modules which give you the VXLAN functionality for switching, and you have this virtual wire, so VXLAN VNI 5001 with your workloads on there. So machine on the first host wants to talk to another machine on the first host. It's local. If you want to talk to a other host, this VM on another host on the other segment, it has to traverse that and learn the MACs and learn the IPs and learn where they are. So without going into too much detail of this, the different modes we have, so you have your VTEPs, there's your endpoints, that's your layer 3, and in multicast mode, the traffic for VXLAN is pushed across everywhere in multicast. So that would have to have controlled installation. It would have to be controlling the multicast between your segment. Unicast mode, all in the hypervisor, sent across unicast, and then sent to a UTEP, so a proxy, and then sent unicast. So the information is sent to a proxy. The proxy is selected by NSX. You can't select it yourself. If it crashes or there's a HA event, it will pick another one. And then it sends it unicast within the segment. With hybrid or high performance, I think it's called high performance mode or something similar inside the platform in the GUI, this is local multicast traffic. So you're offloading a lot of it to the transport network within the segment, send it by unicast to a proxy, so it's not outside that segment, so maybe top of rack switch, and then multicast locally, so you offload a lot of the work. So IGMP sleeping doesn't need a reboot if it's not enabled. Most of them enabled now. Multicast would need a reboot and more control within the data center, and unicast is ease of entry. So for the exam, really understanding what the different modes are, when we use them, what kind of support would you need to use hybrid, those sorts of things. You need to have some sort of multicast support, what the MTU size is, what a VTAP is, what the VXLAN is, so virtual extensible local area network, what slicing is, so you have a controller. A controller is a VM which is deployed from the NSX manager. You bring that up, they're in a cluster. You can have 3, place that into a fully automated DRS with some DRS rules that says don't have them all on the same host at the same time. And that gives you your slicing functionality. So that's our getting ready. So a stable platform, vSphere 5.5 and vCenter 5.5, a distributed virtual switch, your transit network, and full DNS resolution between the NSX manager and your ESXi hosts. Things that I've seen is that if you can't do forward and reverse lookup from your NSX manager to your ESXi hosts, it will start making things like the NSX controller, and then it will delete them at the end. Also, part of the objectives is to know the prereq and also the permissions, so permissions to add and power on VMs, copy files and move files to these data stores, understand the licensing, so Enterprise Plus, understand changing the MTU both at the physical network and also at the DVS. Again, this is just for the VLAN that is between the VXLAN. So this is your VXLAN presentation network. And our order of installation, so we have our NSX Manager, our OVA that you download from VMware, which has just been released. I think you can actually download it now, 6.1. Prior to that, you had to have a relationship with VMware, but now I think you can take that. Someone correct me if I'm wrong. I think I've seen it on the public site. You then register it to the NSX Manager. So you're saying, I want to have a relationship and have our management plane. So that gives us the ability to use the objects together and create our VXLAN, create our edge devices, our DLR, distributed logical routing, and our distributed firewall. So all those features are done in a single pane of glass within our vCenter using our vSphere web client. But the NSX Manager is the in-between factor. So you need to have port 443 between the platform and you install this virtual machine. You give it a license and then you create your controller cluster. So tips behind this is to install the first one and let it run. So this could take about 20 minutes when I've been playing with it in my home lab. And then once that comes up, it can then create the next cluster. So you can have the next 2 VMs running at the same time. So then it can join the cluster. You then prepare your hosts where you deploy your VIBs. So there is a VIB for VXLAN, there is a VIB for distributed firewall, a VIB for the DLR, and a security VIB. So they're the VIBs that we have. A good tip for the exam is to know what's a kernel module and what's a VM. So the Edge Services Gateway is a virtual appliance, very similar to VCNS. That Edge Services Gateway gives us services such as breaking out into the real world from VXLAN to VLAN, load balancing, those sorts of things. Site-to-site VPN is another big one. SSL VPN to dial in with SSL VPN Plus. That's preparing the hosts, so you get them ready to make your layer 2 over your layer 3. So you create a layer 3 network with your VTEP using your VXLAN, create this overlay, and then you can create logical switches, distributed logical routers, edge devices, and firewalls. So at that point, the install time, that's once only, or once per host, for example, in some cases. Then at that point, you've got creating logical networks, routing, edge firewalls, and distributed firewalls. So I put in the brackets there, BAU. Who would do this work in real life? So my point of view, this could be perfect for me talking to a network engineer, getting a stable network. Maybe it's an outsourced platform. They provide a great transit network. Or, for example, I can make a VM, but I want to have different VMs of the same template, but they're different projects. So they can't have intermingling between that. So I could make a VM in 20 minutes, but then I have to go and talk to a network engineer to create a VLAN, which would then be presented to me, which I can then add onto a port group. Then I could copy all these VMs, maybe not even changing the IP. I could copy the VMs on this non-routable VLAN, and then have a hotbox having 2 interfaces, one in the VLAN and one in a network that I can connect to, and then present them quite quickly. However, I still have to wait for that point in time for the VLAN to be presented. And if you're a service provider, that could be a bottleneck. I know in previous companies, for me, it could take 3 to 4 weeks, maybe even months, to get changes on the network due to the impact of how many people you've got on there and the consideration and what could possibly go wrong. So by keeping it static on the transit network and then presenting the opportunity to make objects, so you're making your network an object and giving you the benefits of programming them. So at that point, the network engineer perhaps doesn't care so much about what's going on, the amount of change, just how it interacts with his platform and do the more interesting things. So who would do that work? That's something I always ask people in classes and people I talk to in VMOBs and things. I'm interested in this because from my point of view, I'm a vAdmin. It could be quite scary, me setting up dynamic routing, so I'm going to be talking to the network engineer a lot, asking this. But it does give me the opportunity to set up a consumer, such as VCAC or something similar, or automate this process. So I could have a template which has got all my application installed, but then go one step further and have a security profile based around it. So this virtual aware or virtual context aware firewall, which I think is the killer feature. You can actually set a rule that says any VM that starts with X, or any VM in this cluster, or any VM in this DVS port group, or any VM in this area, or with this VM tag, has certain rules. Even if you vMotion from one host to the other, it's there as well. So it gives you the abilities for me, the network engineer, and the security guy all to agree on something, and then we let someone self-serve it and get a VCO person and an automation engineer to sort it all out for us. So maybe the person who does it is a client themselves. So there's some great thoughts behind it. What's going to happen, I don't know. So here's our demo. So we've got our prereq. We've got this process, our NSX manager, which is an OVA, make this virtual appliance, deploy it, register it with the vCenter, have this compute stack, which is our ESXi footprint and our NSX enabled domain, give them a VM kernel port with a DVS switch being pre-made. That then allows you to create VTEPs, which is in our network ID, with a range of IPs we can use for that. Our transport zone is another term we look at. That could be the logical statement of what we want to enable for VXLAN. So if we have, I don't know, 6 racks, 3 racks we want to have NSX, 3 racks we don't. We would have a transport zone that says those 3 racks with those ESXi hosts are part of the transport zone. Create our virtual wire, which is a logical network, by pushing these VIBs. So within the GUI, which we're going to shortly go through, you install NSX Manager, you go to a web GUI, you can register your vCenter, then you log into your web client and go networking and security. You go to host preparation and you can prepare the host and push the VIBs. You can go to the controller, fetch the status and deploy your Zookeeper controller cluster. That gives you then the ability to make your logical switches. Or within the web client at that point we can start making logical networks. We can start deploying edge devices automatically. We can make some firewall rules and we can go through distributed logical routing. So we can have basically a whole data center and networking stack from a single pane of a web vSphere client. So for vAdmins with some network knowledge, this is a very powerful tool. So going on, I've got a little recording that we can go through, which is here. So you install it from an OVA, register, install the cluster, prepare your VXLAN, create logical switches, and then go through in the demo. So installing NSX Manager from a web client, select the local file. So I've got an OVA. I sign my life away in my EULA. Pick my Elastic Sky cluster from my home lab. So this is just a normal, speed it up quickly because you'll get very, very bored very quickly if you've done virtual appliances. But here's some key points. You enter the password. So this is your CLI admin password for your NSX Manager to customize your template. Then look at your DNS settings. So make sure you can resolve both forward and reverse in ESXi names. Power on after deployment, and this management address in your management network will then be your endpoint for the next part. So here it's going to deploy it. You see at the right hand side of recent tasks, 6%, and it goes on to up into 100%, reboots the machine, gives it the IP and the configuration that we've just done within our OVA package. And then we go to a web browser. And in this web browser we can connect directly to our NSX Manager, which is in our management plane. So here we are. So you've got your login here, and then you're presented with this. So a little bit about this virtual appliance management area. So on the top right hand side you can see what the version is. So that's quite handy to see where you are within the platform, what build you are. When you do an upgrade you can confirm it by logging in after it reboots. You've got syslog. You can pipe up, and also your NTP settings. You do your upgrade from here. Also, backup and restore. So for the exam, know how you back up the platform, why you need to back it up, which areas are where. So for example, firewall rules and the logical network configuration and edge devices are within the NSX Manager. However, the distributed virtual switch configuration is inside the vCenter. So you need to take a copy of that. How would you back up from a DR perspective? What would you do from a change management perspective? So from change management, you could take snapshots of the NSX Manager, the controller cluster and associated control plane. You could take a copy of your DVS switch from 5.5. You can then export that. And the backup and restore, you can have a copy of this platform, so the configuration created in the NSX platform, in the NSX Manager database, and pipe it to, say, a CIFS or an SFTP server. And you can do that daily, weekly, that sort of thing, and push it across. So it's not set by default. You have to place it. You have to set up a scheduled task. So we're going to look at our vCenter registration, a part of our install in our objective. So there's our build number that I'm going across. Here we'll go to manage. So these are generals and entity settings, and then manage our vCenter. So here's edit, and associated with the vCenter and a username and password for NSX. So here I'm going to type in my vCenter details, my username and password, and it will come up with the normal cert, SSL cert prompt at that point, saying hello, I'm here, here's my thumbprint. And then this will associate with a one-to-one association between the vCenter and the NSX manager. So you can't have, at present time, two vCenters connecting to an NSX manager. So it's predominantly a single site deployment for an NSX enabled domain, predominantly for VCP level. So here's connected, and you've got your lookup service at the top for V501 and above, but here's your connection to your vCenter server. And at that point, it's all in the web client. So here's the web client, you log in, and you get a nice little extra pane. This is here, and you see it, networking and security. So inside there you can create the rules, create the cluster, create routing, create edge services gateways, which gives you the ability to do site-to-site VPNs, load balancing, all sorts of interesting stuff that can enable someone to do pretty much anything they like within the network stack. So from a pod perspective, for example, if I was a business stream and I had a 1 gig link out to the internet, maybe out to a well-known cloud provider such as vCloud Air, this would give me the ability to do all sorts of services without having to talk to any network changes on the physical impacting all the people. So here I'm going to create my cluster. So we've now got our management plane complete, and now we're going to look at our control plane. So here we go into networking security. This is our NSX Manager integration. We're talking to our NSX Manager there. You can see the version. We can now see we've got no controller nodes. So this is our VTEP table, controller cluster. So we need 3 of them. So we give it our data center where we can aim it. So we could have a management cluster. So for example, you could have 2 clusters connected by a VDS switch. Connect them together, have a management compute section, and a compute for your workloads. So the management could be a smaller vSphere 5.5 HA and fully automated DRS platform, which gives you the ability to have DRS rules for your control plane VMs that we're going to make, and it wouldn't impact our data plane. So here going through that, we have a distributed port group which is linking our transit network to connect to a network. This is configuring the options to allow NSX Manager to deploy another appliance, which is a controller. And there's a little bit here which says there's a IP pool. So this is the IP pool for your area. And then going further into this, it gives you a password. So this is the password that will be then placed on every single controller. So this will then deploy one, and you can repeat them. This will give you the ability to SSH, which I think I've shown in this video, into your platform, into your controller, SSH in, and checks things such as show control cluster status. So here you can see a VM is being deployed. You can see it's being automatically built. And here's the spec. Yep. Then you can go to SSH, put it in, show control cluster status. You can see that there's a join complete, the trust majority, and then you can prepare and make your 2 other ones. So you now got 3 controllers, go through that process, make the VMs, they come up. The hint is DNS, and then 1 controller comes up first. Wait till that works, wait till you establish the control cluster, and then put the other 2 in. Then we come to making our VXLAN. So this is where we're going to prepare our hosts for these VIBs that we're going to push. So you can see we've got the cluster being picked up by the integration with the vCenter, and our current status, which is installation status, is install, and the right hand side with VXLAN, it's configure. So we're now going to push those things across, install it, and now we're pushing our VIBs out to our ESXi compute stack. Nicely sped up, so hopefully no one falls asleep while I'm talking. So here you can see it's installing through this single pane of glass. And you can see fetching the hosts and see the status of all of them. So by the end of this, it should look like that. Ready, ready, enabled, enabled for everything. And then you know it's working, or you've got enabled. Then you can configure your VXLAN. So now we've got our VIBs, we've prepared our hosts, and now we're going to configure our logical switches. So configure VXLAN networking. So here we give a identifier, the cluster we're going to go to, the NTU size, what teaming policy, and a VTEP ID. So this pool of addresses is what addresses we're going to have across our area. That will start to make, remember my earlier drawing, it starts to create this platform in our NSX enabled domain and stretch our layer 2 over layer 3. So here we give it a segment address. So here we're creating our VNI range. Looks like my video went slightly there for a second, excuse me a second. So we're creating our VNI range. This is here. It shows our segment IP pool. And this gives us the ability to say 5001 to 5099 is that many number of VNIs. So for people who are not familiar with VXLAN, we replace VXLAN with replace VNI with VLAN, and that gives you the same concept. These are logical network segments. So you would need a DLR, a distributed logical router, to talk between a VM on one logical segment to another segment. This is how you're pre-populating the addresses within this. So we're going to be using unicast in this demo, so we're not going to be having any multicast addresses. But for the other types, you'll be looking at adding in a multicast address. So this is what you'll be talking to your network engineer at a VCP level. And you create your transport zone. So our transport zone, we can select the cluster. This is how you're applying a logical extension to your network. So you're saying, I've got this host, this cluster, and these racks with a top of rack switch are all connected. So you're stretching it across on what mode, what control plane mode. So here we have multicast, unicast, and hybrid. So optimized unicast mode is the hybrid. So here you create it, unicast, enable it, and can put it across your transport zone. So I'm going to say in this compute stack, the whole of the compute. So you could have one global transport zone across your whole NSX enabled domain with a VXLAN across the whole platform, and then create your workloads across it. or you could have segments that are like this area is specifically for one client. It is their own area, they bought it, it's NSX for that platform, only them. You could select that cluster and have it enabled only for that platform. Okay. Then we create a logical network. So this logical network, we could make a web tier, an app tier, and a DB tier, for example, in a 3-tier app. And then you need to connect them together using a router. So maybe you've got a web tier 192.168.1, an app tier 192.168.2, and a DB tier 192.168.3. So if you've got them on the same host in a vSphere platform without NSX, the traffic would be, is it local or is it remote? If it's remote, so a different segment, out it goes to the physical network. So with a DLR, with a distributed logical router, distributed meaning the VIBs have been installed on every single host, it will then know that the traffic, it will stay local. So it removes that problem of having hairpinning. So here we're going to make our VLANs or VNIs rather, and we can override this mode per logical switch. So here we've got unicast. So here's our transit network, app network, web network, so web tier, app tier, and DB tier. At this point you can have a 3-tier app, several web servers attached to an app tier and a DB tier on a DLR, have an edge device which has got one NIC peering out to the external network or using OSPF, pushing out the routes, have your web app and DB tier connected to a DLR to remove the hairpinning, but then having users connecting via the edge gateway with NAT being presenting, with load balancing presenting the Windows web servers in the web tier. So that's how you could have that topology quite quickly. And then all these are virtual objects which then you can then copy over and over and over again. Okay. So that's our logical network. Yeah. Did someone ask a question?
Yeah, would you actually mind just briefly explaining what hairpinning actually is? Because for vSphere admins, that's usually not a task, not a term you hear day to day.
No worries at all. Yeah. So if you have, for example, a normal vSphere platform, and you have 3 different port groups, and we've got a web tier, an app tier, and a DB tier, so you've got 3 different types of machine. The web tier is normally in a different network for security reasons, and it various other bits and pieces from the rest of the tiers. So if you need to communicate from the web tier to the DB tier, for example, you would have to go through a router, and vSphere doesn't have one of them at the moment, without NSX. So you would have to, even if the VMs were on the same host, on the same switch, but in different port groups, the traffic would have to leave the physical host and be routed using the physical network. So we're reducing the traffic and keeping the data local inside the host by removing this problem, and that problem is happening. Hopefully that answers the question.
Yeah, great, thanks.
No worries at all. Cool. So carrying on, so we've now built in my demo, we've got a web, an app, and a DB tier. We're now adding our VMs to our logical network. Again, we're doing it from the web client. You're adding and selecting these VMs, and you place them on this logical network. So if you go into, say, a VM, it's like a physical machine being made virtual. This virtual machine does not know it's had its network virtualized. It's still got an IP version 4 address. All we're doing is we're abstracting that, like we abstract our virtual machine hardware using the hypervisor. We're using the hypervisor with a different module to remove it from the network on that side of things, so virtualize our network. So here we're selecting our VMs, place it on this NIC using the VM NIC, and this VM NIC can then have connections to a DLR, which is the distributed logical router, or it could also be connected and controlled using the distributed firewall at the VM NIC level. So all these rules I'm talking about you could apply at the kernel level, but executed at the VM NIC. So for example, I can say the web tier and app tier don't talk to each other, even if they're on the same segment. So here's my logical switch being made. Got my app tier, how many hosts are connected to it, and what virtual machines are there. So here you've got your segment ID, so 5000, 5001, 5002, 5003. Those could be VLANs, for example. On a physical network, we only have one VLAN. We have our transit network. Then we have a web tier, an app tier, and DB tier, which is 3 or 4 clicks of a mouse on your GUI. Your segment ID, which we pre-populated in our ID range, and then our control plane mode for our VTEP, ARP, and MAC tables, which are using the controller-based transport. So the last part in Objective 4 for the walkthroughs is creating an edge. So an edge device. So the previous client, if you've used VCNS, it's very similar. So it's a virtual appliance. It's got a management plane using the NSX manager. The control plane is inside the VM. So this is a virtual appliance. It's not a kernel module. It provides the services such as VPN, load balancing, and so on. NAT, SSL VPN, also IPsec, stretch layer 2 from one part of your cloud out into the external cloud, so you could stretch it using an edge device. You can have dynamic routing. So for example, you have this DLR that we've been discussing and our hairpinning being removed by this platform. If you want to go outside the network and talk to a VLAN, for example, you deploy an edge, and this edge would allow you to communicate with the outside world. So from a physical perspective, when you build it, you would have a port group on a normal VLAN, and then you would have a VXLAN, and you create the interface from the VXLAN and plug it into a edge services gateway, which can do the routing to the external. But there's only one of these. For example, you build one. This would be a virtual appliance, and then it does give you the ability to have HA mode with a dead time of about 15 seconds, I think. Dead time meaning that when it fails over, it's declared dead. So things such as VPNs, etc., would have to be reconnected, but session persistence and other things such as load balancing can carry on. You can have up to 10 interfaces because it's a VM, but it gives you the flexibility to do a lot of the other services. Here, it's all browser and wizard driven. So here you're making a virtual appliance that allows you to connect to the outside world. So click Add. And we get our description. So Edge Services Gateway. Edge Services Gateway Virtual Appliance. Logical Distributed Router is a VIB and enable HA. So for Edge Services Gateway, we're going to make one in an active passive. So you have enable HA, have active passive. DRS rules are created, and then if one goes offline, the other one takes over. But the dead time from 15 seconds by default to 6 seconds is a constraint, but not normally a constraint for business users. Then you put your CLI credentials in, enable SSH, where you can SSH in and do some show commands from the show command management guide you can look at OSPF, neighbors, etc. And configure your deployment. You've got different sizes. So here you've got the appliance size, compact, large, extra large, and quad large. So in the exam, know what sort of recommendations these are for. So for example, load balancing would be extra large. You can offload to things such as Intel cards, so your Intel CPU can offload the SSL for example for your VPN. Configure your interfaces. Have an internal or uplink. Uplink being the outside network and internal being logical. Configure your subnets or your static routing, or you can enable OSPF and have dynamic routing. This is creating your edge. So in the GUI, we're going through this quite quickly in the interfaces. This is pre-populating an OVF build. Again, the MTU on this is 1500 because it's the workload. This is within the VXLAN branching out to another interface to the real world. And then that makes your edge. So in this, we've gone through very quickly. You build your OVF, or you deploy your OVA for NSX Manager, associate it with your vCenter. That gives you the ability to make a management plane. Deploy your controller, your first one, wait till it finishes, ensure you've got DNS, it brings up the control cluster, add the other two, then you've got your control plane. Create your VXLAN, which then pushes with your host preparation screens, pushes out the VIBs and creates your VXLAN, which means you can then create your transport zone and your network IDs to then create your layer 3, presenting your layer 2 with logical networks. At that point, we can then create our VLANs in our current platform, our different network segments, without talking to our network engineer, for example. And at that point, we can remove problems such as hairpinning, we mentioned, more rapid deployment time. And if you want to break out, we start making the Edge Services Gateway, which is here. And that's a VM, up to 10 interfaces. It's got an HA mode, different hosts, specific dead time. You've got different sizes depending on how much load and what services you're going to place on there. So for example, you could rate up to 10 gig with some of these appliance sizes. There's a nice guide I put out on my links that shows you the different sizes, when to use which one, which could be a good hint for the exam. And then you're creating your platform out. So that's our demo of the most of installing the platform from Objective-4. But then we're looking at the upgrade. If there's any questions on the install? Anyone have any other questions on the install? What the components do? Why you do it? Are we okay to carry on with the upgrade? Yeah, okay with the upgrade. So in the exam, there's an upgrade from VCNS. So you could have, like my previous client, I used to have an installation where I had a management cluster with VCNS, with vShield Manager, and then Enterprise Plus with a compute stack. So the process for this, from a high level, is you upgrade the management plane, create the platform to give you your VIBs, so your control plane and then your logical switches. So you create your wire across your platform, and then your edge devices. So here we've got upgrade to NSX Manager. You need to only have vShield 5.5 to NSX Manager 6 is only supported. So that's a nice hint for an exam. vCenter 5.5 is required. You download the upgrade bundle. So it's a different download. It's not an OVA, it's a bundle that you go into vShield Manager, which is an appliance. Very similar topology. Go into settings and reports, upload the file, click install, wait till it reboots, and then log in and you get the very nice NSX Manager on the same IP address. You just upload, you've updated your appliance. Create your logical wires. So you click update, it will say legacy of the status. Click update, you'll then push the VIBs to the nodes using DRS and maintenance mode. If it's fully automated, it will just move the VMs off. And then install your controller cluster and create the logical network. Then you go to the edge device. So the edge is a virtual appliance. You can then upgrade them from actions, and you can see the version number change. So quite an easy transition if you do it in the right order. So for the exam, know the order, know which ones, know which product and what component is in which pane. So you've got management, control, and data. What's actually involved in the workload, or what's actually involved from device to actual device. And then an NSX upgrade. So we've already had a different release, 6.0 to 6.1, and throughout the year I've been using different versions, 6.0.1, 6.0.2, and they have bug fixes between them. So to go through that, you download your upgrade bundle again, go to your NSX manager like we did in our GUI, and there was a big button that said upgrade. Upgrade it, log in, and on the top right hand corner you've got your version number. And you can log into your web client, go to host preparation, click update, and then go through an upgrade on that. So you've got your management area, your compute stack, and your edge upgrade. So again, upgrade your management, upgrade your control plane, and then upgrade your edge network. So as long as you do it in the right order and follow this process, you can pretty much answer all the questions. So any questions on what I've covered so far? I know it's been quite quick. There's quite a lot to go through if you just jumped into it for the VCP. There's a lot of terminology. So I've got some links to some well-known bloggers that have done a great job in documenting some of the terminology. But as a summary, NSX to me is the enabler. It allows me to have this toolkit. So giving me the Edge Services Gateway in VCNS in my previous company allowed me to do all sorts of things. So the Edge Services Gateway connecting out to a hosted provider can just change how you do things. Know the components. So we have our NSX Manager, which then connects to our vCenter via registration. It then connects to our compute stack. It allows you to create a controller VM. So that's a VM, 4 GB RAM, 4 virtual CPUs. They are having the map table, the ARC table, and the VTEP table. They're in a Zookeeper configuration, so there's 3 of them. You have to create your anti-affinity rules. That then gives you the ability to create your VXLAN, pushing out your VIBs. You've got several VIBs, one for VXLAN, one for distributed logical routing, one for your distributed firewall, and also a security module. Those VIBs are your data plane. Once you've pushed them out, you can create your VXLAN using VTEP, your endpoint, which is your layer 3, which is from your IP pool, which then you create your network IDs, that range of what VNIs or VXLANs you push through. That process can then create your abstraction away from your network, assuming you have your prereq, which is a DVS switch, the right version of vSphere, stable vSphere platform, the NTU of 1600, and once you've chatted to your network guy, keep talking to him, get him on board, or if he's going to be doing it for you, help him out with the VMware knowledge, because I've seen some network guys who are fantastic networking, but they panic when they see a GUI. It's like maybe vAdmins who panic when they see a command line interface. Other tools you can use, so we're talking about VIBs. VIBs can be added in using Image Builder. So you can add in these VIBs using Image Builder and then place them into auto-deploy. So you could have a unified image, and then all you do is you associate them to your NSX platform through your controllers. So there's other ways of that. So here, NSX Manager, OVA, virtual clients, register it, put it to your vCenter with your database. That gives you access to the objects inside the vCenter, gives you one single way into your vSphere web client. Anywhere you've got a vSphere ESXi footprint, you can then take advantage using your VIBs and taking advantage for your NSX. Have a DVS switch, which then terminates on a DV port group, which presents a VLAN on the physical network with the NTU size change, which gives you the VTEP. These VTEP create your layer 3, which then allows you to create this layer 2, which is your VXLAN with your VNI 5001. It pushes VIBs, which is your VXLAN, your distributed firewall, and your logical router. And your controller cluster, which is your Zookeeper. So must see the majority. So if you lose one, you're okay. If you lose two, you're kind of in a bad place. Then you have to do a restore. Now the restore process for the exam, that was something I revised before I went in. And then here's our overview. So MTU size 1600. There's a hybrid replication mode, a unicast replication mode, or multicast. NSX Manager is in the management plane. Edge Services Gateway is in the data plane but has its own control plane. Your distributed firewall is in the data plane, it's a kernel module. Your DLR is a kernel module. Your controller VM is a controller cluster, uses slicing, has your MAC, your ARP, your VTEC table. Your control VM is one per instance of DLR, which has your LIF information for logical routing and also your dynamic routing peering information, so that would help you peer with your Edge Services Gateway for things like OSPF. DRS and HA status, so Edge Services Gateway is a VM. If it goes off, you lose your VPN. So you can have a HA configuration, which allows you to have active, passive. It takes over, the other one will pop back up on HA, so it gives you a nice reliable platform within the constraints of the dead time and restart time of these VMs. So our useful links, so I'd recommend, these are all on my website, so elasticsky.co.uk/DCPNV. I have about 60 practice questions on there that I've written, which are as close as I can make them to the exam. I found them quite useful writing them before I took the exam. There's Anthony Burke, who's from the NSBU. Fantastic website here. This is pretty much his notes to NSX. It's fully updated to 6.1. I can't recommend that highly enough. It goes through the packet walkthroughs are perfect for this. Really, really, really good. For home labs and proof of concept, download the step-by-step guide. It goes through every single screenshot that you need to do in the walkthrough that I've just gone through and more. So that's quite nice to get your lab kit going. Me personally, I run a nested ESXi install. So I have four physical machines. Each host has 2 or 3 ESXi hosts. I have a very cheap eBay special switch that gave me the ability to do IGMP and change the ATU size, and I'll just leave it because I'm dangerous on switches. And then you can pretty much do all the things in this POC step-by-step guide that will get you through most of the labs. Recommended hands-on labs before you go, I found them very useful. The biggest aspect is getting access and hands-on to this product. There's an introduction and an advanced one. These are really useful to go through all the screens, know what click is where, break it. You're on your own, you can just trash it, get it back again for 4 hours. So the way I think with networking and all kinds of platforms is conceptually and logically how things connect to each other. And Haney Michael, who was actually on one of my courses recently, absolutely brilliant diagrams there. He goes through every single component and how they link to each other. Absolutely brilliant website. And then some YouTube videos with some great names on there, so Yellow Bricks and VCDX or NSX Ninja, Chris Wah. If you're not a networking person, I would recommend Chris Wah's Plura site download. Absolutely brilliant to go through the CCNA VC, gives you a good overview if you're not a network person. So I've detailed that in my website. And coming to an end, any other questions by anybody? Everyone reasonably happy? Just a quick thank you. Thank you to Frank for guiding me through this and recording it. A nice chat with him. Thanks to Greg for setting it up. Michael for the email, and the rest of the VBandBag team. If you've got any questions, I'm not an expert. I'm just a guy like yourselves who's playing with it, getting used to this new technology. But I've done the VCP, I've done the course a few times, so drop me a bell, I can try and help out, and maybe have a chat with you. So if there's no questions, I think we're done.
I would actually still have one question for you.
Of course.
Yeah, just in terms of real networking knowledge, any recommendations by you on which technologies to really concentrate on? I mean, the blueprint seems kind of to be routing protocol heavy, so we would need ISIS and OSPF, for example, right?
Yeah, you need ISIS, OSPF, IGMP. Understanding IGMP helps. So, for example, when you power a VM on, it lets, so if you've got 3 VMs and 3 different VNIs, a host that doesn't have one of the VNIs, it wouldn't opt in. That would be reflected in the VTech table. So things like the walkthroughs that are in the VCP are quite helpful to understand some of the dynamic routing concepts. So I revised IGMP, ISIS, OSPF, know the difference between ARP, MAX, so ARP resolution, what MAX for, what basic switching is. So really understanding, I think from the VCP level, it's understanding what a physical network would do, how to communicate to a networking person, and then know enough to configure the NSX after getting advice from a network person, I think. So I think the CCNA data center and part of the CCNP gives you the information.
Yeah, brilliant.
Sure.
Thanks a lot for presenting.
No worries. Thanks, mate. Thanks everyone for it. Hopefully I'll see you at VMworld, mate.
Yeah, if you ever want to do anything again with us, just drop us an email.
Thank you.
Yep, the same goes for the rest as well. We are always looking for presenters. You don't need to be a professional presenter to present on the vBrownBag. We are very open in that regard. So if you're interested, just drop us a tweet or an email via professionalvmware.com. And yeah, thank you all for attending.
Thanks, guys. Cheers all.
Bye-bye.